Okay, today is May the 6th, 2016. Right now at 11:30 p.m. in the foothills of Los Angeles, we have a barometric pressure of 1,014 millibar, or 29.93 inches. Temperature is 52 degrees. The relative humidity is 97%, and the dew point is 51 degrees. Okay, right now we're watching a very large area of low pressure right here over the entire West Coast. And one of the things we're watching here is in this circulation pattern is some very severe thunderstorms, some of which are being sucked back around into this vortex. But notice what's happening right here. We have a cell right here being blown apart. We're going to take a look at that here in the next in the infrared loop. And this thing here just completely disintegrates. There's a huge circular hole, and we really get to see that on the visible light mode. Now there's a couple of frames that have been completely taken out of this sequence. It's the actual frame that would show the initial hit by the either the microwave or laser or some weapon to heat transmitter to heat this area right here. So if we go back to the water vapor map, we can see that this area here is completely blown out. You can really see it here in the infrared loop right there. We just scroll through this very slowly. Now we have two frames that are the same right there. So they took out the initial hit. There's the second frame of the hit. And then this whole thing just collapses and we end up with a big circular pattern right there. There's a big circular pattern where the transmitter hit right dead center, just right on top of Eureka, it looks like, Eureka, California. And so what's happening is as these severe thunderstorms are wound back around the low, they are systematically killing them off so that they don't bring rain back into California. That's the plan there, obviously. And the whole thing repeats. We're just going to repeat this sequence again. Now let's go ahead and look at this in the visible light mode, because this is where we really see the detail. All right, this is the beginning of the loop. Keep an eye right here. Now they left out the first frame. This should be the first frame, but they took that out. Now here's the first blast right here. And watch that hole open right up. There's a circular crater right on top of that weather system right there, that band of thunderstorms. And then we see it get bigger. And the next thing we know, the whole area is gone. It superheats that area, and it destroys the organization of those thunderstorms as they wrap back around. Let's just go ahead and run the thing. Okay, so that's being blown apart. The reason is because we have we have a huge area of low pressure spinning here, and California did get some rain today. The foothill communities got a smattering of rain, ranging from about a quarter inch down to about maybe a 1/16 of an inch, just depending on where you were. So, but we should be getting a lot more rain. It's all being manipulated by these transmitters, like what we're seeing here, and also off the Channel Islands. They have these transmitters that just seem to evaporate all the moisture as it wraps around. You can see here that these just don't quite make it around back into Southern California. So that's what's happening. And then also we have a flow here. There's a developing gale way out over here, and that is being steered out of the way with all this high pressure that's on top of this system, keeping it in place. Now let's go take a look why this system here is parked in place. If we look at the East Coast, look what's happening here on the East Coast. We have an even larger low pressure system spinning here, and this has a transmitter. We can see all that heat surrounding that. There's a channel of dry air right here, which is preventing this moisture field from wrapping into that vortex. Right, all through here, there's a barrier, an electronic wall. We can see that if we go to the rainbow loop, we can see that huge channel of dry air all through there, and that is preventing all of this moisture from wrapping in and feeding that system. So as this spins over the East Coast, this has been spinning here all day. This is probably the second day. Yesterday, this was sitting right over Virginia as well. So they're not going to allow this system over here to move in, that is to move east, while this system is here parked. There's high pressure way out here in the Atlantic. We can see that clockwise rotation. That is halting any eastbound movement of this system. So in the meantime, we've got another system backed up over the California coast. And so that's why nothing is moving, is that these weather controllers do not want this system to move into this area and get mixed up with this. Otherwise, we'd have quite a show, quite a storm. Okay, let's take a look next at the Northeast Pacific, the big map on the west coast. We can see a developing gale right here north of Hawaii. There's a transmitter right here on this, working on that. We can see all that dry air, and that is going to follow this well into the west coast. But this transmitter that's on top of this system here is providing quite a barrier, which we can see. None of this moisture here is going to get beyond this barrier right here that they have built around that one system that's sitting over California. So if we look at the infrared on this same map, we can see that they have quite a guard zone here, fence built that's not going to let any of this moisture interact. All right, and there's the East Coast once again. So we have these two systems that are just stalled. This one is stalled right over the East Coast, Pennsylvania, Virginia area, just sitting there spinning, just much like what's going on here on the West Coast. Let's take a look at this up close. We can see this is the western U.S. map, water vapor. We can see all these storms wrapping around, but they're being killed off. We can see one here being blown apart right there. They are killing these off so that they do not wrap around and get into California down here in Southern California, where the drought is still very, very severe. Also, we have a separate operation right here. We can see a big hole in that core. That's not the core, or rather the center of the core. The center of the core is pretty much right about here. Okay, so this is unnatural. This is a man-made feature, much like all the rest of this stuff we're watching. Okay, let's take a look at the, there's the visible light mode. We saw that. They're hitting this storm with some microwave energy, possibly laser. We don't know exactly how they're doing this, but it is being done. Now here is the west central water vapor loop. We can get a better look at what's happening right here over Eureka. They're blowing that thunderstorm apart right here. These cells are all being blown apart before they get offshore and wrap around back into Southern California. This is quite an interesting bit of evidence we're looking at here that demonstrates weather manipulation. Once again, there's that great big hole here, hitting that right there. And notice that is a huge area of moisture just being wiped out. It takes a lot of power to do that. It's possible they're using lasers to do this, because of the within just about 4 or 5 frames, we're seeing all that moisture just completely disintegrate. And look at this. This is all red. If we go back and take a look at the, let's go back and take a look here. There's a fire. I think it's in this province right up here. I can't remember if it's the second one or the third one over, but this whole thing could be pushed north. If these guys wanted to move this storm, they certainly can. They could push it north using all this high pressure, they could just bulldoze it north. I've seen that happen many times. There's a very serious fire I just saw in the news, hundreds of homes burning. The fire is supposed to double in size in the next day. But here's the situation. We've got moisture moving right in through Canada this way, and we also have an opportunity, tremendous amounts of water right here that could just be pushed with high pressure, just like they can push a hurricane. Hurricane Joaquin, September 30th. If you go to my video, September 30th, last year, August 28th, 9th, 30th, 31st, September, let's see, pardon me. Just look at the videos right around September 30th, Hurricane Joaquin. They actually bulldozed that hurricane back out of the Gulf of Mexico, back into the Caribbean, and that's all on these videos I've been making. Yet, is anybody that hasn't seen that, that's a must see. Okay, running out of time here. Let's go take a look next at the. Let's take a look here. This is the west central map, and we're going to scroll through this very slowly. Here's the first frame. They actually took out, they skipped a frame here. They have two frames that are identical, so they removed one frame to hide the actual blast pattern on top of that thunderstorm. Now we have this frame. This is the center of the hit. And here's the second hit. We can see the size of that crater just doubles in size. And then right here is the third frame. Here's the fourth frame. Here's the fifth frame. So we'll just walk through this again. Look at that. That is enormous. And that wipes out a whole area of moisture right over the entire Northern California coast. That is really something. Okay, let's watch that for a minute. All right. Okay, next let's look at the surface analysis map, and we can see that we have a developing gale right here north of Hawaii, 1010 millibar system, and we have this high pressure indicated off the west coast. And we have a trough indicated. This is the west coast here. We have that huge area of low pressure spinning. We'll keep an eye on that. But that is pretty much the summary for tonight. I'm running out of time, and those are the only maps I had pulled up. But we'll definitely do another update tomorrow to keep tabs on this stalled system, and also this system here, which is stalled over Southern California, or the entire west coast actually. All right, so we'll just leave it right here. Watch that system. Huge hole right there. Okay, that's it. We'll do another update tomorrow.